So far we've looked at neutral solutions and water, and now we've looked at strong acids. How does that differ when we get to a weak acid? How is a weak acid different from a strong acid, and what does that mean to the concentration of hydrogen ion and hydroxide ion? That's what I hope to explain in this video. Now we're going to discuss weak acids and how they differ from strong acids. So we already know that acids ionize in water to form hydronium ions. These are going to be called weak acids because they ionize a very small amount, less than 50%. In the strong acids, they ionized 100%. And here's the tricky part. When I say less than 50%, is 20% yet less than 50? Is 30? Is 40? Is 27? All of those numbers are less than 50%. So we don't know the exact number, we just know it's a small number. For purposes of identification, we need to know if something is a strong acid or a weak acid. It's very easy because you memorized the list of 6 strong acids. So if you know those 6 strong acids, all other acids are weak acids. Okay, so now let's look at the math. We're going to move this down. We'll talk about it later. We're going to focus on numbers that you kind of have seen before. Let's assume that we have 100 particles of this acid, in this case hydrogen acetate, which is a weak acid. How much do we have at the start? We have 100 particles at the start of the acid, and then we have none of the hydrogen ion and none of the acetate ion. And now let's look at after the reaction. If we assume that less than 50% of it reacts, we don't know if that's 50% or 40% or 30%, so let's make it 40%. If 40% reacts, that means 60% are still here, and only 40 have converted over to the acid and the acetate ion. But what if I had picked a different number? What if I had said, you know what, no, I think it's not 40%, I think it's only 30%. That means I would have still 70 here and 30 here and here. So you see how it depends on the acid. All that really tells us is that in weak acids, we are not able to determine exactly what the number is. We can pick a range, but we don't know the exact number. So from this, we do know that there is some acid forming, because we said it is an acid and it forms hydrogen ions in the water. So we know there's some. We just know that there is some, but it is less than a strong acid. This is important for our calculations. So here's how we handle it. Since we don't know what it is, we don't know what it's equal to, we just know that it is between, if it had been a strong acid, and what it would be if it were no added acid. The problem is, this is not 0. If we have it in water, it is still going to be 10 to the negative 7 molar in hydrogen. Let's compare the calculations that you would do for a strong acid and a weak acid. Let's start with the strong acid. So we've already done this before. We know that our initial concentration in this case is 0.10. The initial concentration of the hydrogen ion will be 10 to the negative 7 because we're in water, and the initial concentration of the chloride ion will be 0 because we've got no chloride just floating in the water. We'll see that all of the HCl reacted, so we have 0 HCl left, and now we've produced 0.1 molar H plus and 0.1 molar Cl minus. And again, those numbers are equal to the original concentration because this is a strong acid and it ionizes 100%. The theoretical hydrogen ion concentration then is 0.1 molar, or 10 to the negative 1 molar, and our theoretical hydroxide ion concentration will be 10 to the negative 14 molar divided by 10 to the negative 1 molar, or 10 to the negative 13 molar. Now, what happens when we have a weak acid? In the case of a weak acid, it is less than 50% ionized, but we don't know the actual number. So start by filling out the form. We know that if we start with 0.1 molar, that's the initial concentration of the hydrogen acetate, the initial amount of the hydrogen ion will still be 10 to the negative 7 because it's in water, and the initial acetate ion will be 0. When we are done, the final concentration of the weak acid will be we don't know, but we know it will be less than it started with and more than 0. And then we know the hydrogen ion concentration will be somewhere between what it would have been if it were strong, which would be 0.1, and somewhere between that and 10 to the negative 7, because we know there is some acid around there originally. And finally, the acetate ion will be somewhere between that range of 0 and the concentration it would have been if it were a strong acid, which was 0.1. What this tells us is that for the theoretical hydrogen ion concentration, whenever we have a weak acid, the answer will always be between two numbers. The two numbers it will be between are the original concentration and 10 to the negative 7 because we're still in water. And our theoretical hydroxide ion concentration will still be looking at that 10 to the negative 14 factor. So now it will be somewhere between 10 to the negative 14 divided by the original concentration, which in this case is 10 to the negative 1, and 10 to the negative 14 divided by 10 to the negative 7, which is 10 to the negative 7. So our theoretical hydroxide ion concentration is somewhere between 10 to the negative 13 and 10 to the negative 7 for this example. Now it's time for you to try some calculations with weak acids to find out what the hydrogen ion concentration and the hydroxide ion concentrations are for various weak acid solutions. Let's start by answering the question, what is the hydrogen ion concentration of a 0.1 molar hydrogen acetate solution? And then we'll ask, what is the hydroxide ion concentration of the same solution? Please pause your video now as you try the calculation yourself. When you return, I will have the answer for you. For all of these systems, we always need to decide, do we have an acid, a base, or a neutral compound? This step is very important because knowing it, if it's an acid, will tell us that it can find the hydrogen ion concentration directly. If it's a base, it will tell us that we can find the hydroxide ion concentration directly. And if it's neutral, we know that we know both the hydrogen ion concentration and the hydroxide ion concentration because they are equal. In this case, we can see that it starts with hydrogen, so we have an acid, and that means it will tell us the hydrogen ion concentration directly. We don't have to do any extra calculations. The next step is to decide whether we have a strong acid or a weak acid. We know that if it's a strong acid, it will tell us exactly the concentration of the hydrogen ion. If it's a weak acid, it will only tell us the range of the hydrogen ion present, so that means it will be between two numbers. And in this case, we can see that we do have a weak acid, which means we do not know the exact number. It's not equal to a number. It will be a range of numbers that we can find for this weak acid. And that means it would be between if it were a strong acid, which is the original concentration, and what it would have been if there were no acid added, and that means the same as pure water. Which case, we will see that the hydrogen ion concentration then is between 10 to the negative 1 and 10 to the negative 7 molar. Next, let's see what the hydroxide ion concentration is. For the hydroxide ion, remember we're going to be using that standard equation that says hydrogen ion times hydroxide ion concentration will equal to 10 to the negative 14. So we rearrange that, putting the 10 to the negative 14 on top and dividing by each of the concentrations. In this case, the hydroxide ion concentration will be somewhere between 10 to the negative 14 divided by 10 to the negative 1 and 10 to the negative 14 divided by 10 to the negative 7, which means our hydroxide ion concentration is somewhere between 10 to the negative 13 and 10 to the negative 7. Let's try one more example of a weak acid. Here the question says, what is the hydrogen ion concentration of 0.0001 molar hydrogen fluoride? And we'll also be asking what is the hydroxide ion concentration of the same solution. Go ahead and pause your video while you try this, and when you come back, I'll show you the answer. Now, as before, we should start by finding out if we have an acid, a base, or a neutral. That's step one. Here we see that we have an acid, so that means that we know the hydrogen ion concentration directly. The next step is to decide if we have a strong acid or a weak acid. And in this case, we have a weak acid. As a reminder, there are only 6 strong acids, and they are HCl, HBr, HI, HNO3, HClO4, and H2SO4. This is not one of those, so it is a weak acid. Recall that if we have a weak acid, the hydrogen ion concentration is going to be between 2 numbers. What it would have been if there was a strong acid present, and what it would have been if there were no acid present. Those are the numbers that it's between. So let's put some numbers in. In this case, the hydrogen ion concentration is going to be between 10 to the negative 4 molar and 10 to the negative 7 molar. Again, that would be pure water. And now let's calculate the hydroxide ion concentration. Recall that to go from hydrogen ion to hydroxide ion, or from hydroxide to hydrogen, all we have to do is use that 10 to the negative 14 factor. So recall, hydrogen ion concentration times hydroxide ion concentration is equal 10 to the negative 14. So if I know the hydrogen ion, I can find the hydroxide by saying that the hydroxide ion concentration is equal to 10 to the negative 14 divided by the hydrogen ion concentration. In this case, we see that then we have the hydroxide ion concentration is between 10 to the negative 14 divided by 10 to the negative 4 and 10 to the negative 14 divided by 10 to the negative 7. And that in calculation is the hydroxide ion concentration then is somewhere between 10 to the negative 10 and 10 to the negative 7. One of the important things to note is that whenever we're doing this thing where it's between 2 things, it's always between whatever it would have been if it were strong and what it would be neutral. And so that means that always the second number that we're looking at is 10 to the negative 7 when we're done. Makes it a little easier for you to look at when you're doing these calculations. So it will be the same answer as if you had done it like a strong acid, but now you just have to know that when it's weak, you have to say the words between, then whatever you would have done if it were a strong acid, and then the word and then the last number is going to be 10 to the negative 7. Hopefully that simplifies it a little for you.